Gas laws and gas stoichiometry, top 50 Cand A. Gas properties and pressure. 1. What are the fundamental properties of gases? Gases have no fixed shape or volume, are highly compressible, have low density, and expand to fill their container. 2. Why are gases easily compressed compared to solids and liquids? Gas particles are far apart, leaving large empty spaces that can be reduced under pressure. 3. Define pressure in terms of particle motion. Pressure is the force per unit area caused by gas particle collisions with container walls. 4. What are common units of pressure used in chemistry? Atmospheres, millimeters of mercury, torr, kilopascals. 5. State standard atmospheric pressure in different units. 1 atm equals 760 millimeters of mercury equals 760 torr equals 101.3 kilopascals. 6. How does a U-tube manometer measure gas pressure? It measures pressure by comparing the height difference of a liquid column between the gas and the atmosphere. 7. How does a barometer measure atmospheric pressure? It measures pressure by the height of a mercury column supported by atmospheric pressure. Temperature and Kelvin scale. 8. Why must temperature be converted to Kelvin in gas law problems? Kelvin represents absolute temperature, directly proportional to particle kinetic energy. 9. What is the formula to convert Celsius to Kelvin? K equals degree C plus 273. 10. What happens to gas particles at absolute zero? Theoretically, particle motion stops completely. Boyle, Charles, Gay, Lussac relationships. 11. How are pressure and volume related when temperature is constant? They are inversely related. As volume decreases, pressure increases. 12. How are volume and temperature related when pressure is constant? They are directly related. As temperature increases, volume increases. 13. How are pressure and temperature related when volume is constant? They are directly related. Higher temperature increases pressure. 14. Why does increasing temperature increase gas pressure? Particles move faster and collide more frequently and forcefully. Combined gas law. 15. What variables are included in the combined gas law? Pressure, volume, and temperature. 16. When is the combined gas law used instead of individual gas laws? When more than one variable changes. 17. What must remain constant when using the combined gas law? The amount of gas. Ideal gas law. 18. What is the ideal gas law equation? PV equals nRT. 19. What does each variable in PV equals nRT represent? P equals pressure, V equals volume, N equals moles, R equals gas constant, T equals Kelvin temperature. 20. When does a real gas behave most like an ideal gas? At high temperature and low pressure. 21. Why do real gases deviate from ideal behavior? Due to intermolecular forces and particle volume. Avogadro's law and molar volume. 22. State Avogadro's law. Equal volumes of gases at the same temperature and pressure contain equal numbers of particles. 23. How are gas volume and number of moles related? They are directly proportional. 24. What is the molar volume of a gas at STP? 22.4 liters per mole. 25. When is using 22.4 L mole appropriate? Only at STP conditions. 26. Why is molar volume not always accurate? It assumes ideal gas behavior, which real gases may not follow. Dalton's law and mole fraction. 27. State Dalton's law of partial pressures. Total pressure equals the sum of individual gas pressures. 28. What is a partial pressure? The pressure exerted by one gas in a mixture. 29. Define mole fraction. Mole fraction equals moles of one gas divided by total moles of all gases. 30. How is partial pressure related to mole fraction? Partial pressure equals mole fraction total pressure. Gas stoichiometry. 31. What is gas stoichiometry? Using balanced chemical equations to relate gas volumes, moles, and reactions. 32. Why can volume ratios be used in gas reactions? Because gas volumes are proportional to moles under the same conditions. 33. At the same T and P, what is the volume ratio of reacting gases? The same as the mole ratio from the balanced equation. 34. What conditions must be constant when comparing gas volumes? Temperature and pressure. Gas density. 35.